Recording has started.
So the main reason, the vernier caliper, there were very few moving parts on it, just the slide. So there was absolutely nothing about it that could go out of calibration. The biggest thing that could happen, temperature variations, metal can expand or contract slightly. And in a dial caliper, those expansions and contractions can throw off your calibration. Whereas in a vernier caliper, because of the nature of how it was set up, if one metal expanded, the other metal expanded, and the gradients, the markings, still lined up as they should, which was really kind of neat. And we'll show, like I said, we'll show you the vernier calipers later. But with the more precision manufacturing, the dial calipers have become reliable enough now. They have pretty much replaced the vernier style calipers. The vernier scale is still very important, and so we will go over the vernier caliper just so you are familiar with the vernier scale a little bit, because it's a way of adding an extra degree of precision even to some of our modern, more precise measuring devices. So caliper really is the most useful or versatile of our precision measuring devices, mainly because it has so many different methods that it can be used to measure. The first two most people are familiar with, and that is simply using it as common outside measurement between its main jaws. You put an object between those jaws and you tighten it down. This little lump here is actually a thumb screw, which has a built-in slippage, so you can use that to tighten it. And when it gets the correct amount of pressure, that will actually start to slip, so it won't tighten any further. It's just a little wheel that you push with your thumb. It's made that way so that you don't over-tighten it and sink into the surface of any soft metals or plastics that you're trying to measure with it. So you can see you would use it like this. Whatever you're measuring goes between those main jaws. And you can get an outside measurement or an outside diameter of a round object by fitting it between those jaws. Then we have inside measurements. You have the back jaws. If you tighten this down here, when this jaw here is tight to that jaw, this will line up with that. They will be perfectly lined up. So as you open up these jaws also move further apart, the exact distance. So you can use that for measuring inside dimensions between objects or within the inside of a circle, like this. So those two are the two that most people are familiar with the caliper. But the caliper is also capable of a step measurement. When the jaw is fully closed, this edge of that part lines up perfectly with the top edge up here. And because that edge back there actually sticks out a little bit, you can use it for measuring a step up or step down, like this here. You can see how that edge is on the bottom. This little ledge here is up on top of that other ledge, measuring the distance between those two surfaces. So that's a step up distance. And the fourth one is a depth gauge. I've actually seen a lot of people cut this little piece off because it sticks out and gets in the way sometimes. But it actually is there intentionally. When the jaws are closed, this edge here lines up perfectly with the end of that. So you can set the base of this main scale, the blade here, on a surface and run that down in there, and that is a depth gauge. It tells you how deep that hole is. That is the reason why it tapers down at the end here, is so for a smaller hole you can actually fit into a smaller diameter hole for a short distance. They make it fatter so that it doesn't bend quite so easy, but for a small hole you can get into it for a very short depth, take a measurement. So you can see that depth measurement just like that. Some people will use that as their step up gauge as well, rather than using the edge of it. Like I said, it's a pretty versatile little tool. So let's talk about reading these calipers. So when we read the calipers, there are 3 pieces of information we need. Excuse me. This is our main scale here, sometimes referred to as the blade or the, I can't think of the other term used now, but anyway, the main scale of our caliper. This is a standard caliper. In other words, it's measured in inches. And there's 2 sets of numbers on that main scale. You can see there's a larger number here, the 2. That is whole inches. Let's say that whatever we're measuring has 2 whole inches in it. Then these smaller numbers are tenths. That main scale at some sort of an indicator on our jaw that moves back and forth here. On this one, it's just this edge right here that we read that main scale at. You can tell where you read the main scale if you close the jaw and you look at whatever part of this jaw lines up with 0 on the main scale. That's the surface you're going to use to read that main scale. So for this measurement here, this is the 2 whole inches, and you can see we're past the 5/10. We start out as 2.5 inches. Now then, the hundredths and thousandths digit come off of the dial. You can see the dial here is labeled 0.001. Quite often they have inches posted on there as well. It's to the nearest thousandth of an inch. So this is on the 15 here. That is 15 thousandths of an inch. So that 15 just gets tacked onto the end of what we started reading here. That reading is 2.515 inches. So now we can go ahead and just move down our examples here. So for this one, how many whole inches is this reading on the main scale?
5.
5 whole inches. How many tenths?
6.
6. Good. And then over on the dial, what do we have?
21.
21,000. So 5.621 inches. So here, what's the main scale reading?
3.
3.6.
6.
And what's the dial reading?
66.
66. So 3.666 inches. So what's this whole reading here?
4 inch, 887 thousandths.
Okay, perfect. We've got the 4 whole inches. When we look at the tenths, we see the 9 there, so we need to decide, is that edge is it just past the 9 or not quite to the 9? And when we look at the dial, we see that the dial is not quite back to 0 yet. So that tells us it's not quite to the 9 yet. So you read that perfectly. It's 4.8 and then 87. So 4.887 or 4 and 887 thousandths of an inch. Perfect. How about this one?
That's 271 thousandths.
Perfect. 271 thousandths. 0 whole inches. 0.2 because, again, the 3, we're not sure if we're there or not, but we look at the dial and we're not quite back to 0, which means we're not quite to that next marking, so it's still 2 and 71. So perfect. 271 thousandths of an inch. This one?
4 inch, 443 thousandths.
Perfect. 4.4 and then 43. So 4 inches and 443 thousandths. Perfect. Let's go to this one here. This one's a slightly different style. You'll notice that the 0 is not lined up with this surface or even close to it. It's offset. So when we look at this jaw down here, this part is the part that is offset the same amount of the 0. If I close the jaw, that would line up with the 0. So that is where we're reading our main scale on this one. So how many whole inches on the main scale?
0.
4 tenths.
5.
5, and then the dial?
63.
63. So this is saying 0.001 inches, so we know that's still thousandths of an inch. How about this one? What's the reading?
814,000.
Perfect. Here, we're right at that 8, so again, trying to decide if we're just past the 8 or not quite to it. We'll go to the dial, and the dial says we've just passed 0, which means we have just passed the last marking there. So yes, it is 814 thousandths. This one.
1 inch, 46,000.
Perfect. 1 whole inch. We're not to the 10th yet, so it's 1.0 and then 46 off the dial. So 1 inch and 46 thousandths. This one?
1 inch, 261,000.
Perfect. 1 inch, 261 thousandths. 1.2 and then 61. Let's do this one. What'd we get?
JCA loader.
286.
486. Yes. We're past the 4, so it's 2.4 and then the 86. Good. Now there's a style that many of you may not have ever seen before. This one here is a 64th of an inch caliper. Rather than breaking the inch into decimals, break it into 64ths. This was very commonly used for cabinet making and things like that. For woodworking, where we're stuck with the halves, quarters, eighths, sixteenths. This one here can be read a couple of different ways. You see you have the whole inch here, and you have 1, 2, 3, 4, 5, 6, 7, 8. There's 16 spaces on the main scale. So the main scale itself can actually be read to the 16th of an inch if you want to just use that. So what's the advantage of using that over just a regular ruler? Well, if you're measuring like a round piece, you can put it in the jaws and tighten it down. Or even just a small outside surface, if you're measuring it with a ruler, sometimes it's hard to get the edges lined up perfectly. The caliper, you can put it between the jaws and you get that nice snug fit so you know you're exactly at the surface. So you can just use the main scale here to measure to the 16th of an inch. Or you can use the dial here to measure to the 64th. So for this current measurement here, we are past the 1 whole inch, so we know we have 1 whole inch. Over on the dial, then we have to figure out what 64ths we're at. So what I usually do is I find the labeled fraction that we have just passed, which is the 1/8. I'm going to turn my 1/8 into 64ths. Well, 8 times 8 makes 64, so 1 times 8 is 8. 1/8 is 8 64ths. So this right here is the 8 64ths line. So now I can count up. This is 9, 10, 11. My needle right now is between the 10 64ths and the 11 64ths. Which is it closer to?
11.
I'd say just slightly closer to the 11. So that's 1 and 11 64ths inches. So for this one, we have 0, no whole inches, so it's just a fraction we're reading. 1/2 inch is how many 64ths? 32. So that's the 32 mark. So this would be 33, 34, 35. The needle's between the 34 and 35. Which one does it appear to be closer to?
4.
That one's really tight, isn't it?
Yeah, it's kind of hard to see here.
Yeah, that one I would say is almost exactly in the middle. So we really go either direction. You guys said 34, so I'll go with that. So it's 34/64ths, which of course can be reduced. 34 divided by 2 is 17. 64 divided by 2 is 32. So we would say that's 17/32 of an inch. How about this one? This one's a little bit more dead on. What's this one read? 'So that mark that I just indicated there is the 5/16. How many 64ths is that? 20 64ths. Good. So 21, 22. That's 22 64ths. Of course, that can be reduced to what?
11/32.
11/32. Good. And we can't forget that we do have a whole inch there. 111/32 of an inch. Now, I agree these are fairly clumsy to use. The good news is you probably won't encounter these in machining, but I wanted to throw them out to you because there are other calipers that use different scales than what I'm going to be showing you today. Let's move on to the metric caliper. So the metric caliper, the main scale here, the 1, 2, 3, and so on, are centimeters. Unfortunately, our dial is labeled, I know you probably can't read that, but 0.01 millimeter. That goes to the 100th of a millimeter. So the way we have to read these metric calipers is we read this not as 1 centimeter, but we read it as 10 millimeters. And this, of course, would be 20 millimeters and on up. So it's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So when we read this one, of course, this is the part that lines up. This is our indicator on the jaw, that piece there. Right now it's at the 3. So that could be just before 30. Remember that 3 stands for 30 millimeters. Could be either just before 30 millimeters or just after. Which is it? Just before or just after?
After.
Just after. It is just past 0, so it is just after. So that is 30 whole millimeters, and then what's the dial show?
31.
31. So that is 30.31 millimeters, or 30 and 31 hundredths of a millimeter. So looking at this, try to make it a little larger for you. So on the main scale there, how many millimeters is this indicating?
23.
23, very good. And then on the dial?
96.
96, so 23.96.
Our eyes on you.
What's that?
Hey. Guess it pays to sit at the front of the class.
Where you can see the board, see the projector. So for this one, what's our reading?
$52.
It is 52 here.
41.
0.41. Of course, that is still millimeters. How about this one?
47. 17.
17, good.
77.
0.77, good.
There you go, finally speaking up.
How about this one?
46.
46, good. Point
50.
50. How about this one?
Oh, gee. Points.
1 inch, 500 and, or 609,000.
Perfect. 1 whole inch. We're at right at that 6, but we just passed 0, which means we did just pass the 6. And then that's 0.9. So yes, 1 inch, 609 thousandths of an inch. How about this one?
1 inch, 896,000.
Perfect. 1 inch, and then we're close to the 9 here again, but we have not quite made it back to 0 on the dial, which means we're not to the 9 yet. So it's 1.8 and then the 96. So 1 inch, 896 thousandths. How about this one?
$27 and millimeters.
27.60. You got it. How about this one?
$28 and 28.
28.28. Very good. This one?
Inch, 137,000.
Good. 2 inch, 137 thousandths. This one? That's the same one for some reason. Let's do this one.
2 inch, 836,000.
Perfect. 2 inch, 836 thousandths of an inch. This one?
22.37.
Good. And this one?
87.81.
86.
It's 86.
86. There we go. Point.
Pass.
You guys seem, you must have had these in the shop already. You seem pretty familiar with them?
Yeah.
Yeah.
Okay, good. The biggest thing that people struggle with, and that's the reason why I jumped back and forth from metric to standard here at the end, is when they go from millimeter to inch, is placing that decimal point in the wrong spot. So that's something to be very careful of. Let's take a look at get rid of that PowerPoint. I'm going to use my measurement applets here. See if I can find the right one. That is not it.
510.
Okay, here is a vernier caliper. We're going to come back to that one in a minute. It's also vernier. Okay, so here's our dial caliper. Put the answers off the screen so you can't see it. What's that reading right there?
Meters.
It's millimeters, yep.
36.2.
36.62, yes.
Oh.
These can be really tough to get adjusted exactly the way you want it. And it might not go where I want it to go here. Sometimes they get jumpy. No, it's not gonna let me put it right where I want it here. Oh, there it is. I had it. There. Read that.
Okay. 40.05 or 4.
40.04.
40.04. Good. A lot of people get confused when you have the 40 and then the 0 here to start with as well. Okay. I think you guys are good with that one. I don't think there's too much with the metric one that I need to go for examples here. Or not the metric, but the standard. Come on. There you go. How about that?
2 inch 9 thou.
2 inch and 9 thou, so 2.009. Good. How about that?
70. My
Sideways.
eyes.
1 and 373, that looks like. So 1.373. Okay, so on to the vernier ones here. I'm actually going to go to the standard vernier first. So this is not the standard, is it? Nope, the other one's the standard. So here's my standard vernier caliper. The vernier scale replaces the dial partially. Part of the dial is replaced. You can see instead of just being 1.1, 1.2, 1.3, 1.4, and so on, you can see there are markings in between. Those are quarter marks. So this is 1 inch. This is 0.025, 0.050, 0.075. That's 0.1. So this is 1.1 inch. 1.125, 1.150, 1.175, 1.2. So those quarter marks give us the 25,000th divisions between our tenths of an inch. Notice this here is the vernier scale that slides with the jaw. That's labeled from 0 to 25. So we read the main scale at the 0 of the vernier scale. So this is 1 whole inch, this is 4/10, and we're past the first and the second quarter mark. So this is 1.450 that this reads. We read the vernier scale by seeing where it lines up with the main scale. Now the problem with this virtual caliper is we're limited to the pixels on the computer screen, so there's generally several of these lines that actually line up. You can see all 3 or 4 of these, that one's a little off, but all 3 of these here seem to be lined up. The 10, 11, and 12 all seem to be lined up. Even the 13 is really close. So you're going to pick one of the middle ones. If I were actually reading this, my camera shut off for some reason. What's going on there?
It's been on for a while.
Been off since the start of the class.
Oh well, so you guys can't see me what I'm trying to show you, but let's see, that's not what I want. If I switch to that one, you can see me there.
Negative. No, we cannot.
Well, let me unplug it quick and plug it back in and see if it helps. Apparently that one just does not want to play with us today. Okay. Well, I'm going to switch it back to my other webcam. It'll cut off the top of my head, but that's okay. So anyway, normally if I were reading one of these, I would actually take it and I would tip it sideways so I'm looking down the line so you can see whether there's any little slight variation in those lines. reading it flat face on like this is really tough to do. I would never read a vernier scale straight on at the surface. I would always tip it so that I'm looking down those lines to see which ones line up exactly. So these applets are a little bit impractical. But we know that it's one of those 4 lines that line up, because all 4 of them line up here. So we would pick one of the middle ones. So either the 11 or the 12 are the ones that line up. Those are thousandths, and it just gets added on to the original measurement. So this was 1.450. Let's add 11 to it, so that'd be 1.461. Now we check here, they used 1.462, so we're off by 1,000. That is one of the weaknesses of the vernier scale, is you have to have good eyes to pick out which line lines up exactly. So it's pretty easy to be off by 1,000. When we replaced them with the dials, like I said, originally the dials were not reliable. Those gears would wear out, or there'd be some slop in the gears. We just didn't machine them precise enough. So there was just too much error. There was more than a 1,000th error in the dials. So the vernier caliper was still more precise. Now we have more precise machining, better dial calipers, so that they actually work well enough that the dial caliper is probably more precise than the vernier, just because people are better at reading the dials. The vernier itself is still way more precise. It's just it's more difficult to read precisely. So like right here, this is 1.9 inches, and then we're past the first quarter mark. So that's 1.925. Reading it at 0. And then we look and see which lines are lined up on the vernier scale. It looks like we're looking at 10, 11, 12, and 13 again. So we'll pick one, either the 11 or 12, one of the middle ones. Actually, it's like it's 9, 10, 11, 12. So it's either going to be the 10 or the 11. Let's pick the 11. So that's 1.925 plus 11 is 1.936 inches. They're going 3.7. So we were off again by 1,000. But you can see how that vernier scale works. For the metric, again, you read the main scale. This main scale is just like the main scale on the dial caliper. The metric doesn't add any extra lines in on the main scale. So we still read the main scale at the 0 of our vernier caliper. So this is 50. Remember, the 5 stands for 50. 1, 2, that's 52 millimeters. Then we read the vernier scale to see which one lines up. You'll notice this is labeled 1 through 10, but there's only 5 divisions in between. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is actually 10, 20, 30, 40, 50, 60, 70, 80, 90 up through here. So the vernier scale only goes down to 0.02 of a millimeter rather than a full hundredth. So what lines up here? Now I'm looking up at the upper end because I look at this and I realize the 0 is almost to the next marking. So I know it's got to be up here on the upper end that things line up. I'm seeing the 78, 80, and 82. So I would say that's probably 52.80, somewhere in there. And there it is. By the way, you see that comma is in there instead of the decimal point? These are European applets that I'm using here. I believe they're German. In Europe, there are many countries in Europe that use a comma instead of a decimal point. So when there's a number written, it's not a comma. You know, they would have 2 381 thousandths of an inch. That's how we're used to seeing it. They would write it as 2,381, like that. Well, when you're using 3 decimal places, that's really easy to confuse with 2,381. We know that it can't be that because if we're dealing with a precision measurement, 2,000 inches is just not very precise. We would never be machining something 2,000 inches in size. So then how would they write, we do 4,300, how would they write that? They just use an extra half space instead of the comma for the thousands, millions, and billions divisions. So be aware of that if you're working with anything that is engineered in European countries. Very possible that you're going to see that notation with that comma instead of a decimal point. Means the same thing. Okay, so with that, for your homework today, there is a packet on Blackboard. This is calipers. Now, I actually put a couple of packets out there. There's calipers and there's a micrometer and caliper packet. For now, just do the calipers. Tomorrow, we'll go over the micrometers and some other things along with it. And then we will pick up from there. So I'll give you the last 8 minutes here to get started if you'd like on that packet if you have it. Otherwise, from what I've seen, you guys